Welcome back to Teacher Gimble's channel. Today we're going to be talking about Geometry, Unit 1, Lesson 5, in Illustrative Mathematics. If you like this video, make sure to like and subscribe so you can see more like it. I think there's a button down there that you can click. All right, let's get started. Problem number 1. This diagram is a straight edge and compass construction of a line perpendicular to line AB passing through point C. So let's situate ourselves with this question. We have line AB, and we have this line that is a perpendicular to line AB. Explain why it was helpful to construct points D and points A the same distance from C. Well, we haven't learned how to make a perpendicular line, but we have learned how to make a perpendicular bisector. And if we look a little bit closer at this, we see that what they did is they created a perpendicular bisector of segment AD in order to create the perpendicular line that goes through line segment AB. So even though this diagram looks pretty complicated, I'm going to go ahead and I'm going to highlight what they did here. This is the radius. They drew circle D with center D with radius AD. They drew circle A with center AD with center A, radius AB, and they drew a bisector. Because this is a perpendicular bisector, we know that AD has been bisected at point C with AC equal to CD. Because this is a perpendicular bisector, we know that this right here is perpendicular to this over here. Now, if we extend AD to AB, it becomes bigger. So it is no longer, this bisector is no longer a bisector, but that does not stop that from being perpendicular. So in order to get that perpendicular line segment, what they did was they created a perpendicular bisector of a slightly smaller segment to create that perpendicular line. And that's why they had constructed segments D and A to be the same distance from point C, because it is a perpendicular bisector. All right, so a lot of these questions here, they're very theoretical, so I am doing quite a bit of talking. I do recommend that if you need to go over and think about what I just said or to re-listen to it once or twice, to make sure to pause the videos and do that. I'm trying to be as clear as possible while also being efficient to respect people's time, because I know you don't want to be watching this video forever. Let's go on to the next question. The diagram is a straight edge and compass construction. Select all true statements. Now, based on the lesson, you should recognize something that looks like this as a construction of an angle bisector. So the angle we're looking at today is angle ABC. Now, I'm familiar with my constructions and how they did this, so I immediately know that based on this construction, EF, line EF, or FA, is a bisector of angle ABC, and it creates two congruent angles, this guy over there on the left and this guy over here on the right. So let's now, with that in mind, go ahead and read our answer choices. Is line EF a bisector of angle ABAC? Yes, it is, and we just talked about that. Now, if you need to go back to the lesson and identify how to create a perpendicular bisector, I recommend you taking a minute to do that right now. Otherwise, we're moving forward. Line EF is a perpendicular bisector of segment BA. Is EF a perpendicular bisector of BA? No, that is not true. Let's cross it out. Is line EF the perpendicular bisector of segment AC? AC is not perpendicular bisected anywhere. No. Is line EF the perpendicular bisector of segment BD? BD goes from here to here. No. I would say no. Line EF is parallel to line CD. No, we know nothing about parallel. And let's move down to our last option. Oh, those are all of our options. So the only true statement that I have seen here is that line EF is a bisector of angle BAC. We don't have any perpendicular bisectors in this case, and we don't have any parallel lines. Let's go on to the next question. The diagram is a straight edge and compass construction of A, compass construction. A is the center of one circle, and B is the center of the other. A rhombus is a quadrilateral with 4 congruent sides. Explain why quadrilateral ABCD is a rhombus. Well, I'm going to draw one extra line to describe this. So AB is the radius of circle B, and that means CB is the same length as AB and the same length as BD. I also know AB is the radius of circle A, and it's the same length as CA and the same length as AD, which leaves us to conclude that CA is the same as AD, which is the same as DB, which is the same as BC, and because all 4 sides are congruent, therefore this figure has to be a rhombus. Let's go on to the next question. Problem 4. A, B, C, and D, or A, B, and C are the center of 3 circles. Which line segment is congruent to HF? So we want to know what is congruent to HF. I see that HF is 2 radiuses and of circle C. I also see that circle C shares a radius with circle A and shares the same size radius with circle B. So let's look at our answer choices. Does AB have the same measure as HF? They're not 2 radiuses. This is definitely not 2 radiuses of circle C, so nope. Does CD have the same measure as EF? Well, C to D, this would be 1 radius here, and this would have to be a second radius, and we don't actually know if that is, so nope, we don't have enough information. DF, we have D to F. Well, D to B is 1 radius of circle B, and B to F is a second radius of circle B, so it is also 2 radiuses. So yes, this one looks good. Don't forget to always check out all of your answer choices. So let's check CB. CB is 1 radius, and HF is 2 radiuses. So nope, that one is not congruent. We are ready to move on to the next question. Problem 5. In the construction, A is the center of one circle, and B is the center of the other. Explain why segment EA is the same length as segment BC. So we have A is the center of one circle, which means this is our radius, so it's congruent to this guy, he's congruent to this guy, he's congruent to this guy. Now, it almost looks like not equal parts, but we know all those pink things are congruent because it is the radius. And then we have B, which is the center. This is our radius, so it's the same. So I'm going to keep it the same color because it's the same length. This is our radius, and this is our radius. So because circle A and circle B share the same length radius, that means any radius of circle B will be the same as any radius of circle A. And EA is a radius of circle A, and CB is a radius of circle B, so therefore they have to be congruent. And that's it. We're done. Problem 6. AB is perpendicular to CD. Okay. In this diagram, line segment CD is the perpendicular bisector of AB. So this dude bisects this dude into 2 equal sections at a perpendicular or at a right angle. Assume the conjecture that the set of points equidistant from A and B is the perpendicular bisector AB is true. Is point M closer to point A, closer to point P, or the same distance from both points? Explain how you know. Well, we're assuming if it's on the perpendicular bisector, it is equidistant. So this point is equidistant from A and B. This point is equidistant to A to B. This point right here is on the perpendicular bisector, so then we assume it is equidistant from A and B. And so yes, it is the same distance from A and B. And that's it. We used our definition that it was given to us in the conjecture, and we went ahead and we drew a conclusion. Now, in the past few lessons, there were several questions that had similar perpendicular bisector questions. So if you need a review, make sure to go back and identify those and give it a review. Problem 7. A sheet of paper with points A and B is folded. So A and B line up and match each other. So we've got a sheet of paper. Let's draw it. And it's kind of folded in half. I'm going to draw it kind of like a book, such that A and B, so they're going to that's A is going to go to B. Explain why the crease of the sheet of paper is a perpendicular bisector of segment AB. Assume the conjecture that all the set of points equidistant from A to B is a perpendicular bisector is true. Well, let's think of our paper folded in half. This is my paper kind of folded all the way in half. All right, and then we have A and B as the same point. Now, A and B is the same distance. It's the same point. So it's the same distance from the crease, no matter how you cut it. All the distances are the same. No matter which direction you go, we're the same distance from the crease. Which tells us every single point on this crease is equidistant from A and B. And we're assuming that the set of points equidistant from A and B is a perpendicular bisector. So because all of the points on the crease are the same distance from A and B, therefore we can assume that the crease of the sheet of paper is the perpendicular bisector. All right, problem 8. Last question. Here is a diagram of a straightedge and a compass construction. C is the center of one circle, and B is the center of the other. So we have C and B. Explain why the length of segment CB is the same length as segment CD. Well, CB goes from the center of circle C to the edge of circle C, and it is a radius, and CD goes from the center of circle C to the edge of circle C, and it's also a radius. And we know the definition of a circle is a set of points equidistant from the center. So all of the radiuses in every circle are always the same length. So because CB and CD are both radiuses, therefore they have to be the same length. And that's enough information to conclude the reason why they're the same measure. All right, we'll finish this problem set. If you have any questions, put them in the comments below and I will get back to you. If you like this video, make sure to like and subscribe so I can keep seeing you in other ones. All right, bye.